So again, Common Core today, G for geometry, CO for congruence, and it's number 10 in the list, and it states basically proving theorems about triangles. Hey, big guy. Okay. So what I have up here for us, and I'm going to highlight them, what the heck are the things. So again, you've got to be able to prove three things of one triangle congruent to three things. So we need three corresponding things, three corresponding parts. Okay? Whether it's angles or sides, right? But you have to have three. You've got to have three corresponding parts. The three that we're looking at, and these are the only three, is side, 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 angle, 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 side, and hypotenuse, leg. Okay? So what doesn't work, we know what does not work is angle, angle, angle. What also doesn't work is the angle, side, side. That does not work either. Okay? These do not work. Bad triangle. Okay? That's the bad triangle. We don't use that at all. So take a look at first example 1, and then let's figure out why these two triangles would be congruent. So first of all, right off the bat, I just see a side to a side, right? So I've got that for sure. But I need two more pairs of information. But I've got a hint. These little arrows mean parallel, okay? So there's some more information up there. So, well, what do you guys see? I need two more pairs of things. What do you see?
The angle that connects them.
Good. Vertical angles. You guys agree with Kurt? Okay, right off the bat, we can say that angle ACB is congruent to angle ECD. And Kurt's right, that's by vertical angle theorem, VAT. Okay, vertical angle theorem. So I'm going to mark it, all right? So I always like to mark them when I get them, so I'm going to mark that one to that one. Okay, good. Thanks, Kurt. So now I got two things, right? I've got a side to a side. I got an angle to an angle, but I need three things. I need another pair.
Line AC is compared to line C.
We got that. I agree. That's given. Totally right. Agree.
Yep.
What else do we have?
B and D.
Why is B congruent to D? I'm not saying you're wrong. Makes the Z. Do you guys see the Z? Or you could even say A is congruent to E, because it makes the Z also. But since Katie wanted to go B and D first, let's do B and D. So you guys see the Z? What's the Z? It's not really called the Z. What's it really called? Alternate interior angle. So let's go angle B is congruent to angle D by AIA. Okay, so let's mark that one. So I got that one congruent to that one. Okay. So let's see what we have. So I've got a side to a side, an angle to an angle, and another angle to an angle. So we have three things. So we can say that triangle ABC is congruent to triangle EDC by my, you ready? This has to be an angle, angle, side. It has to be angle, angle, side. Nice job. Because you've got the angle, and the side that we're looking for is not in between the two angles, right? The side is not here, but it's here, so that's why it's an angle, angle, side. Okay? Thumbs up. You okay with that? Okay, good. Didn't see a lot of thumbs up, though. Thumbs up? Sideways? Alright. It's tilting. Okay, example 2. Why are the two triangles congruent? Well, right off the bat, one thing I see for sure, I know that 100, so angle Y has got to be equal to angle W. You guys agree with that? There's the 100, 100. And I also see that the 30 is equal to the 30. So for sure I've got a angle, angle, right? I've got an angle, angle, but I need something else. And the two triangles I'm looking at is probably this triangle here, right? And the other triangle I'm probably looking at would have to be probably the other one, right? Should be this triangle here, okay? right? They look equal, don't they? They look equal. And the reason I chose those two happened to be the fact that the two angles are angles of those bigger triangles, right? So I need a third thing. Silence is golden, isn't it? I need a third thing.
Line YZ is congruent to line WX.
Yes, but we don't know that. We don't know that, not yet. There's something else. Because why would you say that? Once the triangles are congruent, I agree they will be congruent, but we can't say that yet. What could we say? Anybody see it? David, do you see it? Well, we don't have parallel lines. Oh, vertical angles? We could do a vertical angle here, right? But that won't help us with the big triangle and the little triangle, okay? Want a hint? Want a hint? There you go. What do you know about that line? Isn't that line the same line to both triangles, isn't it? You had it, didn't you, Hunter? So XZ is the same line for both triangles, right? Which means it's got to be equal to itself. So how can you say that? I'm going to say XZ is congruent to XZ. What's the reason? It's looking at itself. It would like maybe look at it in the mirror at its reflection, so it's reflexive. Nice job, Hunter. You had it, didn't you? So now, what are the three things we have? We've got a angle, angle, and a side again. We've got the angle, angle, side, right? Angle, angle, side. So I'm going to say that triangle, XYZ is congruent to triangle. Let's see, it had to be ZWX. Triangle ZWX, right? By what reason? Angle, angle, side, right? Angle, angle, side. Okay, good. So now, example 3. Well, I've got a side to a side, and I got an angle, right? But here's a hint. It's a right triangle, right? Here's a hint. So it's probably going to be probably HL. So if this is the case, if this was a right triangle, this really is the hypotenuse right here. That's the hypotenuse. That's really the hypotenuse. So we really already have the hypotenuse, right? We got the right angle, and we need a third thing. We've got hypotenuse, hypotenuse, right angle to right angle. We need a third thing.
Oh, the one in the middle.
They share, don't they both share the side, right? So this side's got to be equal on both sides. So we could say that this side's equal to this side by, and I didn't label this, but we also have a reflexive, right? Because they share this side. And that's a leg in a right triangle. That's a hypotenuse. That's a leg. So we'd say that the triangles are congruent by HL, or hypotenuse leg. Okay? How's that? You started to catch on a little bit? Okay. Example 4. Oh, it's a proof. We love proofs, don't we?
No.
Yes, we love proofs. But you know, we can all get the first step. First step's easy. What's step 1?
The given.
It is the given. So AB parallel ED, and we're also going to say BC is congruent to DC. Okay, all right, reason for that is given, right? So let me mark my figure, because that always helps me. BC, that's that one. DC, let's mark that one. And I got parallel lines, right? So I've got this line is parallel to that line. Okay, so I want to mark my figure, okay? That's parallel there, and that's parallel there. Okay, so step 2. You ready? Angle A is equal to angle E. Where did that come from? Angle A is congruent to angle E. Where did that come from?
Oh, the Z.
See the Z? You guys see the Z? Right? Right? And that's not, we don't call it the Z. What do we call it? There you go. Alternate interior angles. Good job, Kurt. AIA, alternate interior angle. So let me mark that. So now I've got that one equal to that one. Good. So now I've got two things. I've got an angle to an angle, side to side. I got two pairs. I need a third pair. So then we get to this ACB, ACB, and ECD. What's that?
Vertical.
Yeah. VAT, vertical angle theorem. So let's mark that. Now, do we have three things? What are the three things? What are the three things? What are the three things?
Angle, side,
Close.
angle, side.
It's got to be angle, angle, side. Why? Because the side is not in between, but it is angle, angle, side. We got an angle to an angle, another angle to an angle, and side to side. So then finally, let's say we have to prove triangle ABC is congruent. Triangle DEC by angle, angle, side. Okay? How you doing on this proof? Sideways maybe? Okay, thumbs up. Okay, the nice thing is with proofs, I will do half of it for you. I'll never make you do the whole thing by yourself, okay? I'll do part of it, okay? Ready to turn the page? Okay, all right. Oh, it's another proof. Oh my goodness gracious, it's another proof. Hey, but it's only got 3 steps, so that can't be too hard, right? It's only got 3 steps. Okay, so step 1 given, right? Angle V and angle Y are right angles. And also I've got my VW is congruent to XY. Okay, so let me mark it. So let's put a right angle for V and a right angle for V. Okay, so I'll mark it. Mark my figure, make a little right angle, okay? And then, yeah, you're ahead of me. VW, I like that. That one's equal to that one, right? And then finally, I already heard it. Thank you, Eduardo. So given. So Eduardo said that WX and XW are congruent by, say it again. Yep, everybody agree with that?
Yep.
So let's mark that. Okay. And then so finally we should be able to say that this triangle is congruent to this triangle by, what are the 3 things? Well, it's an angle side side. It's an angle side, but we can't say angle side. That's a bad word. It can't. So what is it? It is the hypotenuse leg because we have a right angle. Nice job, Kurt. It is going to be HL, hypotenuse leg. So we're going to say then the triangle VWX is congruent to triangle YXW. Nice job. Okay, so homework today. Page. Up. Sorry, Jaden. Give me thumbs up. So homework, page 256, 4 to 8 even, 11 to 17 odd, 22 and 39. Okay, not too bad.